Hey guys, welcome back to my channel. We're continuing with the playlist for IGCSE Edexcel Maths A. We're doing questions for upper bounds and lower bounds today. If you're someone who's not aware of this playlist, please check out the link above because it contains several videos which are divided topic-wise using past paper questions from 2018 onwards. Each video has different level of questions for each topic, so it's going to greatly help you in your exam prep. So let's start with this one. It says the length of a ship is 142.8 meters correct to one decimal place. We have to write down the lower bound and the upper bound. So these type of questions have like 2-3 steps, and if you follow those steps, they're very like straightforward. There's nothing complicated going on over here. Whatever the value is correct to, in this case, it's one decimal place. One decimal place is basically 0.1. That's the place value for one decimal place. So what you do is you take your place value of one decimal place, which is 0.1, and then you divide it by 2. So 0.1 divided by 2 is 0.05. To find the lower bound, what we do is we subtract this from the given value. So 142.8 minus 0.05, that gives us 142.75. Now to find the upper bound, what you will do is the opposite. You will add it to 142.8. So that's going to give us 142.85. So as you can see, it was just like 2 steps. First step is to identify the place value of what it's correct to. So the place value of one decimal place is 0.1. Then you divide it by 2, and whatever value you get, you add and subtract it for the upper and lower bound. For the upper bound, you add the value to the given value, and for the lower bound, you subtract it. And you have your answer, simple as that. So this was like the basic type of upper bound and lower bound question you can get. Now in this question says the weight of a cat is 4.3 kgs correct to two significant figures. We have to write down the upper bound and the lower bound. Now in the previous question, it was correct to one decimal place. This is correct to significant figures now. So in this case, what you do is, since it says correct to two significant figures, you first look at your number and see what is the place value of the second significant figure. Second significant figure is 3. So place value of 3 over here is 0.1. So again, we divide 0.1 by 2, which gives us 0.05. Then for the upper bound, we will add this to 4.3, which gives us 4.35. And then for the lower bound, we will subtract this from 4.3, which gives us 4.25. So simple as that, you have to identify the place value of what it's correct to. If it's like correct to two decimal places, then you identify the place value of the number that's the second decimal place, which is 0.01. Divided by 2, and the value you get, you add and subtract based on what you're trying to find. Then it says G equals to E minus F. E equals to 17 correct to the nearest integer. F equals to 9.4 correct to one decimal place. Work out the upper bound for the value of G. Okay. Now, this is slightly more advanced than the one that we were doing. The previous two questions were like the basic levels, and now we've increased the difficulty level. So when you're trying to find the upper bound and lower bound in difference, like in subtraction, if it's the upper bound, then what you do is you subtract lower bound from the upper bound. And if it's the lower bound, you subtract upper bound from the lower bound. That's how you find the upper bound and lower bound in difference. Because look, if we're talking about the upper bound, then we have to take the smaller value out from the bigger value. That's why we're taking away lower bound from the upper bound. It's not upper bound minus upper bound. Because if we did upper bound minus upper bound, you would get the biggest value. Similarly, for the lower bound, we have to take away upper bound from the lower bound to get the least value. Because upper bound is bigger than the lower bound. And if we did lower bound minus lower bound, that wouldn't give us the least value as well. So remember, in difference, you're taking away lower bound from upper bound. And in lower bound, you're taking away upper bound from lower bound. If it was addition, then you do upper bound plus upper bound, then it's like very logical. And lower bound is lower bound plus lower bound. This is the rule that we follow when we're trying to find the upper bound and lower bound in addition and subtraction. So based on the formula that they've given to you in the question, you just write your cheat code, which is upper bound minus lower bound. Lower bound is lower bound minus upper bound. And for upper bound and lower bound addition, it's the same thing. You write it down and then you see what formula you have and which one you have to choose. Now for the upper bound of the value of g, we need the upper bound of e and lower bound of f. So for upper bound of e, 17 is correct with the nearest integer. So nearest integer means 1 whole. So 1 divided by 2 is going to be 0.5. So upper bound would be 17 plus 0.5, which is 17.5. And for f, it was correct to 1 decimal place, which means 0.1 divided by 2, that's 0.05. So lower bound would be 9.4 minus 0.05, which is 9.35. So now for the upper bound of g, it's going to be 17.5 minus 9.35, which gives us 8.15. That's the upper bound of the value of g. Now, if you look at this one, it says a equals to p minus q over t, where p is 8.4, correct to two significant figures, q is 6.3, correct to two significant figures, and t is 0.27, correct to two significant figures. Work out the upper bound for the value of a. Show your working clearly, giving your answer correct to 1 decimal place. So we have subtraction happening in the numerator, and then overall it's division. So two different things. So I've already told you the rules for subtraction. Now let's discuss the rules for division. Overall, the question says that we want the upper bound of a. So for the upper bound of a, we divide upper bound by lower bound. And if it was lower bound of a, we would divide lower bound by upper bound. That's the rule that we use when we are trying to find the upper bound and lower bound in division. So based on that, we need the upper bound of p minus q and lower bound of t. So for upper bound of p minus q, we know that we will do upper bound of p minus lower bound of q. We've already discussed the difference rule. So this is what we need to find for the numerator. So p is 8.4, correct to two significant figures. So second significant figure is 4. Place value of 4 is 0.1. So 0.1 divided by 2 is 0.05. For the upper bound, we will do 8.4 plus 0.05, which is 8.45. Now for q, need to find the lower bound. So again, q is 6.3, correct to two significant figures. Place value of the second significant figure is 0.1. So 0.1 divided by 2, 0.05. Lower bound is going to be 6.3 minus 0.05, which is 6.25. T is 0.27, correct to two significant figures. For t, we need the lower bound. So second significant figure over here is 7 now. 2 is not the second significant figure, 7 is. When you have decimal numbers, the 0 before the decimal, that's considered insignificant. So we start counting from 2. So 1, 2. So 7 is the second significant figure, and place value of 7 is 0.01 now. So 0.01 divided by 2 is 0.005. So for the lower bound, we will do 0.27 minus 0.005, which is going to be 0.265. So for the upper bound of a, it will be 8.45 minus 6.25 divided by 0.265. That's going to give us 8.30. They want the answer correct to 1 decimal place, so 8.3. That is the upper bound of a. So for upper bound and lower bound, you need to be familiar with the rules that we follow when we have addition, subtraction, division, multiplication. For multiplication, let me write that. So if you're trying to find the upper bound in multiplication, you multiply upper bound with upper bound. And if you want to find the lower bound in multiplication, you do lower bound times lower bound. So for addition and multiplication, it's simpler. For division and subtraction, the rule is like kind of the opposite. We're taking away lower bound from upper bound for upper bound. We're taking away upper bound for lower bound. So it's like that. If you're still getting confused about this, I'm attaching a link above for a short that I've made on this. If you go to my short section, you'll find several shorts that I've made on upper bound and lower bound separately, with each category differently, like addition separate, multiplication, subtraction, and division. So you can go through those, and if you still have any questions, leave a comment below and I'll help you out again. Now, if you look at this one, it says A equals to 3.46 correct to three significant figures. B is 6.3 correct to one decimal place. Now we have X equals to 6 over B minus A, and they want the upper bound of the value of X. So if they want the upper bound, that means your numerator is going to be the upper bound and denominator is going to be lower bound. So for A, upper bound is going to be, so for the upper bound of A, we look at A is 3.46 correct to three significant figures. Third significant figure is 6. So place value of 6 is 0.01. Divide that by 2, which is 0.005. So upper bound would be 3.46 plus 0.005. That's 3.465. Then for the lower bound of B minus A, we need lower bound of B minus upper bound of A. So for lower bound of B is 6.3 correct to one decimal place. So 0.1 divided by 2, which is 0.05. And then we do for lower bound 6.3 minus 0.05, which is going to be 6.25. So 6.25 minus 3.465, and that is going to give us 2.785. So for X, the upper bound is going to be 6 times 3.465 divided by 2.785, which equals 7.46 correct to three significant figures. That's your answer. Then this one says diagram shows a rectangle ABCD with rectangle EFGH cut out to form the shaded region. We have to work out the upper bound of the area of the shaded region. So we know that AD is 8.3, DC is 7.2, EH is 6.2, and HG is 5.3. So for the upper bound of the area of the shaded region, what we do is we subtract upper bound of A, D, B, C and lower bound of E, F, G, H. So basically upper bound of the area of ADBC minus lower bound of the area of EFGH. That is going to give us the upper bound of the area of the shaded region. The reason why we're doing this is because to get the shaded region, we subtract the areas. So when there's subtraction, and if you're trying to find the upper bound, it's upper bound minus lower bound. Since it's the upper bound for ADBC, that means we find the upper bound of AD and DC. And since they're being multiplied, so both will be upper bound. And for EFGH, you will find the lower bound of the length. So upper bound of AD. 8.3 is correct to one decimal place. Place value of one decimal place is 0.1. So 0.1 divided by 2, 0.05. So it's going to be 8.3 plus 0.05. That's 8.35. Now for the upper bound of DC is 7.2 correct to one decimal place. So same thing, 0.1 divided by 2, which is 0.05. And then upper bound is going to be 7.2 plus 0.05, which is 7.25. Now we find the lower bound of EF and GH. Now we find the lower bound of EH. So EH is 6.2 correct to one decimal place. Same thing for this as well. 0.1 divided by 2, that's 0.05. Lower bound is going to be 6.2 minus 0.05. It's going to be 6.15. And for GH, again 0.1 divided by 2. So I'm going to just skip that step over here because I'm running out of space. So that's going to be 5.3 minus 0.05, which is 5.25. So now for the area, we will do 8.35 times 7.25 minus 6.15 times 5.25. This will give us the upper bound of the area of the shaded region, which is 28.25. That's your final answer. But this one says the diagram shows triangle ABC. C is 11.5 correct to one decimal place. X is 80 correct to nearest whole number. And Y is 75 correct to the nearest whole number. We have to calculate the upper bound for the value of B. Show your working clearly, giving the answer correct to three significant figures. So we know C is 11.5, X is 80, Y is 75. If you're someone who knows about the sine and cosine rule, you can easily look at this triangle and identify that we'll use sine rule to solve this because we have one complete set of angle and length. If you don't know about sine and cosine rule that well, please check out the link above because I made a separate video about the questions for sine and cosine rule using exam questions, and you'll find a variety of questions over there. So let's first create the formula first so that we know what values we're going to need. We're trying to find B. B divided by sine of angle B equals to C divided by sine of angle C. So B equals to C times sine of angle B divided by sine of angle C. This is our formula. And since we want the upper bound, that means for the numerator, I'm going to need the upper bound, and for the denominator, it's going to be the lower bound. So keeping that in mind, we need the upper bound of C, we need the upper bound of sine of angle B, and we need the lower bound of sine of angle C. So for upper bound of C is 11.5 correct to one decimal place. So place value is 0.1. 0.1 divided by 2, 0.05. So upper bound would be 11.5 plus 0.05, which is 11.55. We have that now. For angle B, we can see that we don't have the angle, but we can subtract these two angles from 180 to get angle B. But since we need the upper bound of angle B, that means we first find the lower bound of 80 and 75, and then we subtract that from 180. Because as you know by now, that when you're trying to find the upper bound in subtraction, lower bound values are subtracted from upper bound. So let's find the lower bound of Y and X. Lower bound of X. 80 is correct to the nearest whole number, which means 1 divided by 2, 0.5. So lower bound is 80 minus 0.5, which is 79.5. Then same for Y. Since it's also correct to the nearest whole number, so it's going to be 75 minus 0.5, which is 74.5. So B is going to be 180 minus 79.5 minus 74.5, which is going to give us 26. So 26 degrees is the upper bound of angle B. Now we plug in the values in the formula and find B. So 11.55 times sine of 26 divided by sine of angle C, which is Y, that is 74.5. That gives us 5.25, correct to three significant figures. That is the upper bound for the value of B. So that's your answer. Then this one says, Kaidan and Sonja went on two different car journeys. For Kaidan's journey, distance is 80 kilometers, correct to the nearest 5 kilometers. Time is 2.7 hours, correct to one decimal place. For Sonja's journey, distance is 33 kilometers, correct to two significant figures. Time is 1 hour, correct to nearest 0.1 hours. Kaidan says, my average speed could have been greater than Sonja's average speed. By considering bounds, show that Kaidan is correct. Show your working clearly. So to show if Kaidan's journey is greater than Sonja's, we need to find the upper bound of Kaidan and lower bound of Sonja's speed. So for upper bound of Kaidan's speed, speed is distance over time. So if we're trying to find the upper bound, for distance we need the upper bound and for time we need the lower bound. Whereas for the lower bound of Sonja's speed, it's going to be the opposite. Since it's lower bound, we need lower bound for distance and upper bound for time. So let's use this information to solve it. So for Kaidan first, the distance is 80 kilometers, correct to the nearest 5 kilometers. So for distance, it's nearest to 5 kilometers. That means we divide 5 by 2, which is 2.5. So upper bound is going to be 80 plus 2.5, which is 82.5. Now for time, it's 2.7 hours, correct to one decimal place. So 0.1 divided by 2, which is 0.05. Lower bound is going to be 2.7 minus 0.05, which is going to be 2.65. Well, let me separate this over here. Now over here, distance, we need the lower bound. So for Sonja, 33 kilometers, correct to two significant figures. Second significant figure is the ones place. So 1 over 2, which is 0.5. So lower bound is going to be 33 minus 0.5, which is 32.5. And for time, it's 1 hour, correct to the nearest 0.1 hour. So 0.1 divided by 2, which is 0.05. So upper bound is going to be 1 plus 0.05, which is 1.05. This is distance, time. So now we can find the average speed and then we can compare whether Kaidan is correct or not. For Kaidan, it's going to be 82.5 divided by 2.65, which gives us 31.13. And for Sonja, that's going to be 32.5 divided by 1.05, which is going to give us 30.95. So it's clear that Kaidan was correct because Kaidan's speed is greater than Sonja's speed.